Hello and good morning everyone, and welcome to the talk on logical data warehouse. We'll be talking on how to build a virtual data services layer today. My name is Sachin Ghai, and along with me is Ajay Srivastav. We work with Impetus Technologies. Part of the Impetus Technologies, we work in innovation labs where we do research and product development and then solution them for real life use case implementations, the products and research that we do across. So as part of the talk today, we'll be talking about the logical data warehouse. What is the meaning of logical data warehouse, how it has emerged in the big data world. Then we'll be talking about specific topics within the logical data warehouse. We'll be talking about virtualization, we'll be talking about offload. So data virtualization, specific use case of data virtualization that we have implemented in one of the financial majors. And we'll go into technical insights of how we implemented that across. And we'll also be talking about offload solution. And again, we'll be going into technical insights as well on the topic. Right, so the data warehouse over the years has evolved. And okay, so it has evolved. And if the slide looked inverted to you, it actually was. So the reason being that the data warehouse, as we knew so far, had inverted the concepts of with the emergence of big data. So the concepts we knew so far for the data warehouse have taken a spin right now. The enterprise data warehouse, as we knew, so we knew that we need to have a schema. So we need to have a schema before we could write anything to the data warehouse. Lots and lots of extensive data governance and controls, auditing, security that we need to build in, data quality measures that we had to build in before we put the data into the data warehouse. Then ANSI SQL compliance. So SQL was the flavor of data warehouse. Anything that you wanted to do, it had to be primarily SQL and procedural SQL for that matter. Any report that you wanted, anything that business team wanted, it had to go through IT. It had to go to the IT team, build a report, go through the development testing cycle, redeploy it, and wait for the, I don't know how many weeks before a business user would get a report out over there. Lots of concurrent users, not just business users, but lots of system users in the data warehouse. And pre-canned BI, anything that we wanted to do BI on, business intelligence on, more or less it was a kind of a pre-canned environment that we had. But then with the Hadoop-based big data warehouse, how it has evolved across the years. So low-cost storage and archive. So commodity hardware. Lots of servers, lots of commodity, inexpensive servers that you could bring in. Low-cost disk space. So the storage became something of a commodity itself, and you could have lots of storage space and do a lot of distributed processing on that. Non-SQL access. So it was not just SQL that was the something that we could be restrained to. With the emergence of MapReduce, Java, Pig, HBase, you could do a lot of non-SQL access to the data that is there in the warehouse. Exploratory analysis. So not just being restricted to the queries that have been built in by an IT team. A business user could do a lot of exploratory analysis, build up his own hypothesis, test them, and work it across to bring around the solutions. Machine learning and graph processing, something which we would have probably struggled with the enterprise data warehouse. Machine learning and graph processing, the advanced analytics, the data science cases became much of a reality, and not just to a specific PhD guy who would be sitting in one university. It is something in the hands of a normal developer now, machine learning and graph processing. Data discovery, another key paradigm which has emerged. So emergence of the data patterns that you could discover, and this is not just some user doing that. Sophisticated patterns could be discovered through tools, basically. Tools and algorithms you could deploy, and data discovery could be done on its own. Self-service BI and analytics. Self-service is again a key theme right now. Again, no dependency on any kind of developer right now. You could do self-service, have a BI tool integrated with your Hadoop-based warehouse. If you know a bit of a Hive, if you know a bit of a Pig, you could do your own kind of BI or analytics over there. Just know a bit of that tool across. So enterprise data warehouse to a big data warehouse, the data warehouse has evolved, has modernized through the various years. And the paradigms has inverted as we see it over here. But the reality is that the EDW and BDW, the enterprise data warehouse and the Hadoop-based data warehouse, are bound to coexist, for at least for a few years or so. So the reality is that both the warehouses, the EDW and BDW, coexist. And some of the reasons for that being that organizations are still on the initial phase of the big data maturity. So people are still setting up their data lakes. At this point, the focus is still on putting the data within the data lakes, then doing some kind of SQL analysis or doing some kind of algorithms over there. But the further advanced phases of advanced data science, the optimization, the quantitative techniques that can come in, they are still not there in many of the organizations. So people are at various phases of their maturity in the big data journey. Existing ETL jobs still feed the EDW. So although you have the Hadoop-based warehouse set up across, but one of the key things which we hear from the various organizations and customers is that my ETL jobs are still feeding into the EDW. I will still have to rework them to get them into the Hadoop-based warehouse, or I'll probably rely just on the Scoop or Flume kind of things. BI and the downstream applications still being integrated to the enterprise data warehouse. Still not all of your BI and the downstream applications are connected to the Hadoop-based warehouse. So one of the key reasons, again, business users still have some view from the enterprise data warehouse, some view from the Hadoop-based data lake that is coming across. And business use cases for big data are still emerging. ROI, the key term that we have been listening all through. So ROI is something people have been figuring out, what's the best use case for big data, I need to do big data. It's an in-fashion thing, but people are still figuring out the right use cases which can go around for just a Hadoop-based or big data warehouse. So the reality is that enterprise data warehouse and the big data warehouse at this point of time are coexisting in most of the organizations, or still have not come across a major enterprise organization which has just moved to the Hadoop-based warehouse. But of course, over the years, we will see that gradually the wave will turn across it, and there would be convergence of these warehouses. But with this coexistence of the big data warehouse and the enterprise data warehouse, there's a logical layer that has emerged across on top of it. So big data warehouse, as we knew, was a single repository kind of thing, a single repository, as the purists would like to define it. Similarly, logical data warehouse has emerged as a key term over here, which says that although you may have multiple data warehouses, so you may have an enterprise data warehouse, you may have a big data warehouse, you may have the NoSQL data stores, but at the end of the day, all of them you can encapsulate and abstract that as one logical layer, as one logical data warehouse. And this is a term which I have not coined. This was coined by Mark Baer of Gartner. It was proposed first in May 2009 and published in 2011 research report of Gartner. Mark Baer is one of the very senior guys in Gartner. In fact, Hadoopsphere coined him as the top big data influencer in its Hadoopsphere top big data influencers report of 2012. So in response to the emerging forces of these enterprise as well as the big data warehouse, so this logical data warehouse layer has emerged. And the key components over here are repository management. So repositories over HDFS becoming a de facto primary repository right now, but there are other repositories of the warehouse that are still there. Distributed process, as we know, MapReduce becoming more or less a de facto standard for distributed parallel processing, but there are other, with Spark coming in, there are other kind of distributed operations that you can do. Data virtualization, again, fits in between repository management and distributed process over here. We'll talk about this in a minute. Auditing statistics and performance evaluation services. So this would be more of the governance controls around it. SLA management, very key, very critical. Most of the users, when they evaluate the tools, SLA management is pretty critical to them. Taxonomy or ontology resolution, so domain specific, telecom, financial, healthcare, taxonomies, and the semantic layer. Metadata management, metadata dealing with the various data sources that we are connecting across, the data about the data, the metadata management. So these are key 7 components of the logical data warehouse. Now new paradigms have emerged through the years. So data lake being one, very popular. being in a Horton work show, data lake is one of the most popular terms over here. And it actually doesn't mean just the HDFS, it actually also now comprises the various NoSQL of the world, to be more precise. Distributed parallel process, MapReduce, as well as various Spark operators. So it's not just map and reduce now that you can do with Spark. There are other things that you can do in an RDD Spark-driven world. Virtualization, it's not a new concept right now. It has been there for some years, but it has taken a new twist with the emergence of the big data paradigms. And offload, how you can offload from a relational or an enterprise data warehouse to a big data warehouse, how you can move the tables and the various code across. So these 4 new key terms have come in across, or paradigms have emerged along with the logical data warehouse. So if you look at this screen over here, so there are certain source systems. So there could be relational systems, so the Oracle DB2 that you might have in your cluster. In a typical organization cluster, you would find some or many of these over there. You would find NoSQL like a Cassandra, MongoDB. You would find file systems like HDFS, GPFS kind of thing. MPPs like Teradata, Netezza, or Hadoop-based warehouse like a Hive or an Apache Tajo kind of warehouse you might find across. So the data over here would be in multiple systems according to the use cases, multiple teams, various silos having different kinds of data in the warehouse. And in terms of target systems, so the target systems would have, so your users could be a web application, mobile application, or it could be a enterprise smart bus, or the enterprise applications which would take in the data from these source systems. Then the BI layer would be reporting visualization layer, data science, advanced analytics layer, data management, MDM, and discovery. So the target systems layer. But either we could have a many-to-many relationship between them, an N-cross-N relation. So each of the systems feeding to the source systems, feeding to the various target system, an N-cross-N relation. Or we could have a common layer of virtualization, which can bridge the gap between the source systems and the target systems. So therein comes the need for the virtualization layer. Specifically with virtualization, this term has actually evolved through the years. So data virtualization in its simplest, purest definition means a simplified, unified, and integrated view. There is another variant of that, and the term is pretty commonly used, data federation. Data federation, now more or less the consensus is that it is a subset of data virtualization. It is enhanced with query optimization strategies. So primarily focusing on the querying part of it. So that's more or less a consensus across. And there's another term which has evolved called data blending. Now in data blending, the difference is that while federation and virtualization deal with a read kind of thing, in blending there is actually a movement of the data. So you do a write also. So you might be writing the data to HDFS or one of the repositories. So there are various delineations or the variations of the data virtualization that you might find with the various literature as well as the various vendors that you might be, or the companies that you might be interacting with. Specifically with our talk today, we'll be talking about how we have built the virtualized data services layer. So we'll be talking specifically on the virtualized data services layer. And I would like to now invite Ajay to talk further on a specific use case that we have implemented for that, and then we'll go deep into the architecture of this.
All right. Thanks, Sachin. So I'll be discussing the wealth management use case, and we started this use case, this project in 2010. And it was having immense possibilities because of these emerging technologies, the way they can transform wealth management from an account-centric view to a personalized goal-based wealth management. But we will be discussing the ideas that Sachin mentioned, and in this particular context, but they are applicable across industry, some of these ideas, and you can see that the problems, we will discuss the problems we faced and how we solve them. So one of the main problems which occurs in this context is when you go for a large project, your information is spread across different lines of business, and they are usually using different sources and platforms. And how do you provide data integration throughout in a timely fashion? So that becomes a very crucial requirement. Okay. So what they really wanted was that even as late as 2010, when you go to when a financial analyst see your data, from the client perspective, what he sees is your account information, your customer information, but he doesn't really understand the goals. He doesn't really understand your lifetime events. He doesn't track your financial security throughout the events happening and how they're affecting your financial security. So that's a big area, and that can provide a major breakthrough in wealth management. So they have the lot of financial analysis that goes on their systems, and they have CRM systems, Salesforce. But as far as understanding their high net worth individual, they still have a very limited view. And that limited view restrains them from getting and really addressing what their client goals are. So that was their major goal, to change that view and have a comprehensive approach to understand how they can apply these technologies into understanding wealth management. And it's fairly large. It's one of the top 5 wealth management firms. And they usually are at the cusp of the technology. But even in 2010, they were not able to do these things simply because the data was not available. Okay. So they narrowed it down to 3 things. First, they wanted to create a household view. They wanted to understand the household structure. And this data, they wanted to first start with their own internal data. And when they try to collect this data, and there could be some retail data or some information spread across the system, and they start with a very simple rule. So suppose they start with a simple rule of collecting this view, and they want to figure out simple rule that if 2 persons are living in the same household address and they have the same last name, they could be related, and by the age, gender, they can figure out certain things. But the problem with that is that even a simple requirement like this can quickly become complex. So if you have 123 Main Street, how do you match it with a different 123 Main Avenue? So now you have string distances coming in. Once you have, so these kind of things quickly escalate. Furthermore, they wanted to integrate it with IVR logs and their web logs. What happens when you call a bank and the information go to the IVR system? You call another time, yeah, the IVR people will understand because they have access to the same system. But if you get frustrated, you go to the retail account, and but you have to again tell your problem from the start because the IVR system is not having a real-time integration with their banking system. So that's a major problem. Similarly, now a lot of people are doing their own investment on the web logs, but that information doesn't really flow to the financial analyst in a real time. So that way there is the 2 information systems goes out of sync. Then they wanted to discover relationship, further deeper relationships. So if they already know your household structure, they can advise you on 529 and other systems. Then they wanted to develop a business network view where they can figure out what is kind of the social standing of the business network this person has. So I won't go into too many details, but they want to integrate it with social data to figure out how this person relates and what kind of business social standing he has. And similarly, for a third major view they wanted to was that for their corporate accounts, they wanted to import the corporate hierarchy and mix it with their financial information. So what does these view gives you? So this household view can help you in your retirement planning, 529, college loans, gift card, estate planning, alimonies. So if you see, it pretty much touches everything what they do. So it's a pretty critical system for them. And not having a real-time integrated view of this system really inhibits them. So it was a major breakthrough from them. And similarly for business network view, which will help them for company loans, asset standing, business prospects. So all this they wanted to achieve. So they were trying to do this with traditional data integration, where data is embedded in silos. And anytime you want to move information from one system to another, there is a time-consuming and resource-intensive ETL process. And it increases latency. So if you have from EDW, if you have to Hadoop, some Bashly process running in, by the time you analyze that information, it's already late. Then you create data duplication. So you have these massive amount of systems. and you are again trying to bring it to a separate repository rather than having a unified view, you go on creating duplicate copies of your own data. Many times governance is inhibited. So if governance is not applied, once you bring the data into Hadoop, you again have to apply governance rules, put the data access structure, which is at current stage, which is not very mature, and then it creates its own problem. And then you have the inability to handle the V's of the big data. Okay. So this is the kind of architecture which has evolved over the years. And what it really helps is this is the data virtualization we put. And in its whole, if you see that you have this migration, and this is a very important concept, and Sachin will be talking in detail about it. So you start with, if you have say 1,200 tables, you can't bring the whole data together. So you start with like 300, 400 tables or 150 tables on your first use case, but you quickly discover that there are different groups asking for more data. And some of your data is still existing in EDW. And your EDW is feeding your current business systems. And you cannot bring the whole data. And then you run in the problem like which data you define as your system of records. So if this is a problem common across large enterprises. So once you define system of records, but you have to bring the data again for analysis, then you again run into the same issues that you ran in with the traditional data integration. You have duplicate copies everywhere. But there's another way. You bring that data and you put your data here. So if you have your data and whatever data you decide, and Sachin will be discussing it in detail, between hot and cold data, you brought some data here, and you want to further integrate it with your OLTP systems. So this is the layer where you can integrate your whole data. So we build a centralized schema, metadata information system, and you can implement rules over it. So you can say that for this customer information, the first 6 months of data you exist in my OLTP systems. But for the last 7 years, which is a banking requirement, if you want some requirement, then you go to Hadoop. And then you abstract that complexity within this layer. So when you are trying to feed into your BI tools, you provide just one common interface. And all the complexity of getting the data from which system and to get what data and mixing it up and providing that unified view, you put that complexity within your data virtualization layer. And this layer can feed your BI system, your analytics, and we also have a very good tool, Kundera, where you can also provide updates. It's a polyglot mechanism. Kundera is completely open source, and you can update different systems. So if you have objects in memory, you can update the different systems, and that complexity is handled by Kundera. So, and recently we have also started doing some POC on how to integrate this web tracking activity that a financial analyst has to do, and put that into the Spark. So, and then you can, once you have the data there, you can have some kind of sync utility between Hadoop and your data virtualization layer. So what does this really give us? First thing it gives us is a fast real-time data integration without creating expensive copies of data. And this is a major headache for big organizations. It gives you significant savings of time and resource required for the ETL process. You can create a final composite schema which you expose to different systems. It gives you information management capabilities. And now because your data exists in memory, you can actually, if you connect, you may have some requirement to connect it to Tableau or other BI systems, you can meet much more stringent service level agreements. So yeah, now I will give back to Sachin for offload discussion. Yeah.
So there are basically two key patterns we are discussing over here. So one is the virtualization. So where we are building a virtual data services layer. So you have data in Teradata, Netezza, or Oracle, and at the same time you have it in Hive, and combined with Spark on Spark running on Hive, or so rather Hive running on top of Spark, and along with these various Spark execution engine layers, we build that architecture of the virtualization. But there's another concept, offload, that we will be discussing. So there's a pattern, virtualization pattern, and there's an offload pattern, where again both the enterprise data warehouse and the big data warehouse coexist as part of the logical data warehouse architecture. So consider a scenario: you have a very expensive luxury couch, and nice cats sleeping on that. So nice expensive luxury couch. You are paid a lot of money for that, but just the cats are sleeping on it and you're still not utilizing it. At the same cost, instead of that, if you could actually get a lot of simple couch, simple seats in your home, a lot of simple seats, and they could seat a lot many number of people. You could have a large party and you could have a lot of people coming to the party across. And at the same time, you could have a good, decent, expensive couch serving the purpose of your seating capacity. So at the same, so translate the scenario, translate this analogy now to a expensive MPP. So expensive MPP existing in a cluster, I'm not sure what that is doing. It's having a lot of cold data in it, lots of cold data in it. It's not doing the value add jobs that you are paying the money for. Instead of that, you have low cost commodity hardware coming in, a Hadoop based commodity hardware coming in, and you could do a lot of jobs running on that cluster. And at the same time, you reduce the capacity of your MPP enterprise data warehouse and just run the value added jobs on that. The exploratory analysis, the advanced data science moves to the Hadoop big database commodity hardware. So multi-parallel PET, I mean a multi-parallel processing engine. Instead of that, you have luxury couch moving to the commodity hardware, and at the same time having a normal decently. So you could offload the data from an MPP to a Hadoop based big data warehouse. So the concept of offload actually is moving the data, the tables, as well as the code that is being used in an enterprise data warehouse to the big data warehouse. So there are two essential components. So one is the tables. So tables, if you see, so you move the tables as well as the data from a relational database to a Hadoop or a Hive-based repository. And at the same time, you move the static SQL, you move the procedural SQL, as well as the proprietary scripts that exist on the big data warehouse. So some of the key challenges which most of the organizations face while doing this kind of offload process is that one is there are a lot of input sources, and most of the people are dependent upon the rudimentary scoop kind of things for connecting to the various tools. So it could be an Oracle, it could be a DB2, it could be a Teradata. So just the rudimentary tools, but the varied input sources and very specialized data sources that you have. Mostly you are dependent upon manual validation that yes, the entire data has been moved, the entire schema has been moved, the number of rows match from its source and relational database to a big data warehouse, whether you have moved the entire data or not, so which is error prone. So you might have a chance of missing how many rows and the data that you are moving from one warehouse to another. Then the NSI SQL incompatibility is one of the key issues. So the SQL which runs on a relational warehouse doesn't run on Hive. Hive being SQL 92 compatible, and it has plans to come up further with further advanced features on the SQL compatibility. But most of the relational databases we know are much advanced on the SQL compatibility. So the SQL scripts which we run on a Teradata kind of environment probably doesn't work on a Hive-based environment. The user-defined functions which we have in, again, the relational databases, we don't have those user-defined functions over in Hive. In Hive, you have certain libraries, but they are pretty limited, and you have to build the rest on your own. There's a lack of unified user integration view whenever you are doing this kind of thing. It's all basically a Scrum Master would be tracking the various jobs, data done, migration done, these kind of tick marks he would be putting across, the backlogs he would be picking across. And of course, the data quality checks at this point are again dependent upon your developer, how many data quality checks he has done at this point. So how we build the offload solution? We built basically, it's a pretty busy slide, but there are key 5 steps on the right side of the screen. So first is we identify which tables have to be moved from one warehouse to another. Second is we define how do we move the schema, and then we move the data across. So we move the table schema, then we move the data across. Third is we migrate the logic. So the logic that is encapsulated in the SQL scripts, procedural SQL scripts also, So Hive doesn't have a procedural SQL layer for that matter. There's no PL/SQL, but we have built an engine of our own which can take your PL/SQL also and run it on top of Hive. Then we do the data quality enhancement. So the data quality checks like deduplication, standardization, cleansing, these kind of things we do across. And the fifth step is we run this or execute these transformed code on Hive. And Hive again on one of the three modes, either Hive on MapReduce, Thais, or Spark, depending upon the requirement. And on the roadmap, we also have, we'll be making it run on Impala as well. So basically, these are something which we do in an automated manner. We have built a UI also for that. And these automated scripts run it across and offload the data across from a relational to a Hive-based environment. So looking at a sample query, this is a Teradata query for a online shopping portal, and whether the item which they sold has been shipped or not. So it's getting an aggregate view of whether the item was shipped in a less than 30 days kind of thing, or a 31 to 60 days kind of thing. So the pretty complex query or lengthy query, I would say. When we do this, run this through our utility, so we have this automated Hive query which gets converted. So there's an insert into table, which from an insert into it gets transformed into insert into table. There's a trim which gets transformed to a user-defined function which we have built, a UDF_trim. Then the literals like 30 days within quotes, so there are no quotes in Hive, so it becomes 30_days. Then if you look at the other reds, so I'm talking about the reds, I'm highlighting the reds over here on the screen. So an extract, day, number of month, TD, quarter, begin, these are user-defined functions which are not available in Hive. So built a library around these Hive Teradata functions which are now available when you run these scripts on top of Hive. And similarly, there's a function like any kind of operator. Instead of that, it translates to exist. So within Hive, there is an exist operation that you can do across. So we have transformed that into exist kind of thing. So this utility basically, our utility basically runs this through the various transformation rules and transform it to Hive-specific user-defined functions, literals, or various operators that are the closest match that can run in Hive. So, and this way we are able to not just run the SQL, but the PL/SQL kind of, or the PG/PL/SQL kind of queries as well, of Postgre, of Teradata, of Netezza, of MySQL, Oracle world in Hive. So key advantages, pretty obvious that we are able to optimize the MPP and relational database resource for workloads. So what workload should run on an expensive MPP versus what workload should run on a Hadoop-based environment. So if you can optimize on the cost of your MPP, why not? Then reuse the millions of lines of code. So lots of dear code that has gone in through the years, along with the lots of dollars that have gone into writing that code. So just reuse that while you have the Hive-based repository. Avoid the relearning, recoding, retesting, redeploy cycle, all the recycles. So you can, so whatever you have done in a relational data environment, you can do the same thing in a big data warehouse environment. And of course, seamless integration of downstream, upstream applications as well as the reports that you get across. So in terms of summarizing this, so the journey to the logical data warehouse. So the key steps that are, we discussed virtualization and offload as the key patterns over here. But from an overall logical data warehouse journey, if you have to go through that. So the first step would be to establish your information data strategy. What is your information strategy? Whether you want to go for some big data components, whether you want to go for NoSQL or not. Identify the key components as the second step. You want Hadoop, you want Spark, you want Thais, you want Tajo, you want Hive. Those kind of components, identify those. Then segregate your workloads. What workloads are best for an MPP? What workloads are best for a Hadoop-based environment? Offload the low cost or exploratory analysis job to Hadoop. Offload the cold data to Hadoop. Then leverage virtualization. So let's say customer call center getting a unified dashboard view, one customer transactions from a Hadoop-based environment and customer balance from a relational database, one unified view, one virtualized view. So figure out the use cases for your virtualization. What are the use cases that where you can leverage virtualization in you? Then of course, establish the key supporting pillars. Semantic meta layer, the metadata layer, the quality, the SLA management. We did not talk through that considering the time that we have, but these are again key supporting pillars, and these form a very essential element of the logical data warehouse, and that's where you reach the maturity of your data warehouse. That's where you would reach that pinnacle across. To sign off, well, in the end, there can be only two types of data warehouse. It can be a logical data warehouse, or pure simple illogical data warehouse. So that's my 2 cents on that. Just don't quote me outside the room on this. Right, so we are open for questions now. And yep. Yeah, so the question is, do we have CDC kind model? Can we do CDC on this kind of data? So yes, on top of Hive as well as, in fact, for HBase also for that matter, we have built a solution which can capture what data gets changed, as well as, in fact, along with that, we have also built the SCD capabilities also, slowly changing dimensions also. So CDC and SCD also we can do. So again, this is an ingrained solution, and we can further detail, talk that offline, how we have built that across. Yeah.
SQL transformation to Hive that you spoke about, I mean, there was a Teradata example.
Yeah.
So is it any kind of MPP you would be able to, be it Teradata, be it Vertica, be it Netezza kind of translation will work, or we'll have to do something different for it to work?
Yeah, so the question is, can any type of MPP work with this solution? So right now we have done it for Netezza, Teradata, and among the relational we have Oracle, DB2, and MySQL and SQL Server. So Vertica is on our roadmap. Right now, it's not there. Yep.
So is there any API layers that you guys use for that middle, so that data, so that can be consumed? So you're creating one bus where all the data can be available. Is there an API?
Yes. So in fact, let me go back to that diagram then. So over here, if you see, there is a query API, query as well as an API layer that we have built across. There's a search API also. There's a REST layer also, and JDBC. Let me point it with pointer. So we have this query layer, the API, REST API, search API, and JDBC. And ODBC also along with that that's a separate connector that we have shown across.
For anyone wanting more information, both Sachin and Ajay will be available in booth S9, that's Impetus Technologies. Thank you for coming.
Yeah, thanks everyone.
Last slide where you had some
Reference slide? Yeah, sure. So these are certain open source products from Impetus. So not all of them are open source, like Kundera, Ankush, Jambune, in fact Stream Analytics being our real-time streaming platform. So these are open source with enterprise support, and we are available on S9 to talk more about that. And another message that HR wanted us to communicate, we are hiring as well.
I think there's one last question, Sachin. We'll take one more.
Yeah, sure.
Okay, thanks. The data you're bringing into Hadoop environment, is it considered to be static? You're not expecting to update it, right, once you bring it in?
Yeah, hi.
I could not get that question.
Yeah, is there expectation that the data is static in Hadoop environment, the one you're offloading from
I'm
MPP?
From Bangalore, actually.
Oh, no.
But
So
we have
incremental
US,
updates are
teams.
also
So you're
there.
actually running
So
updates
you
on
can come
that?
to the
Yes.
booth S9.
Okay, that's
and we
it.
can
So
connect.
updates means we create new directories, or we do the entire delete and insert
Okay,
again.
so you're actually doing that.
And in
right.
fact, we are using Hive 0.14 further now, which also has update capabilities.
Okay, interesting. All right, thanks.
All right, thank you very much. Thanks for joining our talk, and see you later.